everyone. Today we will be continuing our discussion of weighted voting with the concept of Shapley-Shubik power. Now, Shapley-Shubik power, in kind of similar to the Bonzoff power that we discussed in the last video, in the sense that it is a way of measuring the voting power of the different players in a weighted voting system. However, the central premise of Shapley-Shubik power is a little bit different than what we saw for Bonzoff power. So Bonzoff power is based on the concept of coalitions of players that vote together that are subsets of all of the players in the weighted voting system. Shapley-Shubik power is based on what we call sequential coalitions. What is a sequential coalition? Well, basically it's just an ordered listing of all of the different players in a weighted voting system. So I have an example right here. We have the weighted voting system 10 as our quota, 7, 4, and 3 as our weights. So in this case, our total number of votes is 14, and our quota is 10. This would be approximately a 2/3 majority vote that's required. Now, basically, when we are figuring out the sequential coalitions for a system like this, we're just going to list out every single possible way that we can order all of the different players that we have. So in this case, we only have 3 players, 1, 2, and 3. So there are 6 different ways that we can order this. Now, when we are figuring this out, there is actually a formula that tells us how many different sequential coalitions we're going to have. And this uses what we call a factorial. So the number of sequential coalitions that we have is going to be n factorial, n being our number of players, in this case 3. So this would be 3 factorial. And what a factorial is basically we're just going to take whatever we're doing the factorial of and we're going to multiply it by every integer all the way down to 1. So 3 factorial would be 3 times 2 times 1, which would be 6, which is the number of sequential coalitions we have here. So when I'm listing out the sequential coalitions, I usually start by listing out all the ones that start with P1. So in this case, there's only going to be 2. We have 1, 2, 3, 1, 3, 2. And then we can do the same thing with coalitions starting with P2, 2, 1, 3, 2, 3, 1. And then for P3, we have 3, 1, 2, 3, 2, 1. Now, when we are determining the Shapley-Shubik power for a weighted voting system, or power distribution for a weighted voting system, we have to determine what we refer to as the pivotal count for all of our players. So this is built on the concept of a pivotal player, and the idea is that when we have sequential coalitions like this, players join the coalition in the order that we have them listed out. So say for this first one, this would be saying that P1 decides to vote yes first and then is joined by P2 and then joined by P3. And the idea is that if we go down the line, the first player that gives us enough votes for our motion to pass is going to be our pivotal player. So if we look at this first example, P1 alone has 7 votes, not enough to get us up to the 10 that we need for the motion to pass. But when we add P2, we now have 7 plus 4 votes, that's 11 votes. That is more than our quota. So that is enough for our motion to pass. This means that P2 is the pivotal player for this coalition, or sequential coalition rather. One thing that's notable about pivotal players is, unlike critical players where you can have more than one critical player in a coalition, with sequential coalitions, there's always going to be one pivotal player exactly in every sequential coalition. So let's look at our next one. P1, 7 votes, not enough. But then when we add in P3, now we've got 7 plus 3, so 10 votes. That is enough for our motion to pass. Next we have 2, 1, 3, so 4 votes, 11 votes, now we have enough, so P1's our pivotal player. Next we have 2, 3, 1, so we have 4 votes plus 3 votes for P2 and P3, that's 7, not enough, but then we add in P1, Now we do have enough, so P1 is our pivotal player. Next, 3, 1, 2. Starting with P3, we have 3 votes, but then we add in P1, now we have 10. So P1's our pivotal player. And then finally, 3, 2, 1. With just P3 and P2, we have only 7 votes, not enough, but when we add in P1, now we do. So at this point, basically, we're going to count up how many times each of our players is a pivotal player. And we call this the pivotal count. So we abbreviate this SS. So we'll write this SS1, SS2, SS3. So we'll start with P1. P1 is a pivotal player 1, 2, 3, 4 times. Next we have P2. P2 is only a pivotal player 1 time. So that would be a pivotal count of 1. Same thing with P3, pivotal count is 1. Now we can actually calculate the Shapley-Shubik power index. The Shapley-Shubik power index for a player is basically just the pivotal count for that player divided by the total pivotal count, which the total pivotal count is always going to be n factorial because there's one pivotal player for every coalition or sequential coalition, and we have n factorial sequential coalitions. So we use the Greek letter sigma to indicate Shapley-Shubik power, or we can abbreviate this SSPI, Shapley-Shubik power index. So for P1, the Shapley-Shubik power is going to be SS1 divided by n factorial. This would be 4/6, or 2/3. So we would say this would be 66.7%. All right. Next, we're going to do the same things with P2 and P3. So this is basically going to give us 1, because we have total counts of 1 for each of these, so 1/6. And this is going to give us a Shapley-Shubik power index of 16.7% for each of these. So we can see P1, as you might expect from having the highest weight, has clearly the highest pivotal count, Shapley-Shubik power. However, even though P1 has half the total votes, P1 has more than half of the Shapley-Shubik power. So once again, this shows that really the voting power, based on something like the Bonzoff power or Shapley-Shubik power index, is not necessarily going to be proportional to the actual weights of those players. Thank you for watching, and if you have questions, I'm always happy to help.